In this lesson, we're going to learn about gases and their properties. So to start with, we'll look at the three states of matter: solids, liquids, and gases. And the difference between those we've talked about in Unit 1 and comes down to the intermolecular forces, which cause different particles to be held close to and not be able to move past or be able to move past one another based on those forces. So also based on those forces are particle motion. So there are three different types. Vibrational motion is the first one, and that is just a back and forth motion. And all states of matter, particles in all states of matter, would have vibrational motion. The second one is rotational motion, which is a spinning around. And liquids and gases would have rotational motion because they don't have to stay in relation to the particle next to them near each other. And the last kind is translational motion, which is a straight line motion. And this will be in both liquids and in solids, where they are able to move away from one another. Now the difference is in gases, the particles can move completely away from one another, whereas in a liquid, that particle can simply move away from the particle that it's next to, but is still going to be close to other particles. So the type of motion here is going to depend once again on the strength of the attractive forces, or the intermolecular forces that we have between the particles, which will determine at any particular temperature whether a certain type of element or compound is going to be a solid, a liquid, or a gas. So if we look at solids, we have a couple of representations here of what a solid would look like. So solids have a definite shape. So as we move them from one container to another, that is not going to change. They also have a definite volume. So the amount of space that they take up won't change no matter what container we move the solid into. They are virtually incompressible, so we can push the particles together a little bit, but there's not a lot of space between particles as it is. So there's not a lot of compression that can happen in solids. And here the intermolecular forces are very, very strong. So even when we're talking about something that is maybe a gas at room temperature, if we are at a much lower temperature where that particular substance is a solid, at that point the forces between the particles would be strong. So for any substance, when it is a solid, there are very strong attractive forces between the particles that hold them near each other. And that is the reason that the rotational and translational motion do not happen in solids. So with respect to the particle, the neighboring particles, a particle is not going to move away. So the only type of motion that particles in a solid have are vibrational motion, which is a back and forth movement, but they stay in the same place relative to the other particles. So liquids, there's a couple of representations of those. Liquids can change their shape, so we can pour them from one container into another and they'll take the shape of the container. They do have a definite volume, so whatever amount of space they take up in one container, they will take up that same amount of space in another container. So if I take 50 milliliters of water in a beaker and pour that into a graduated cylinder, then it will still be 50 milliliters. It will simply have a smaller diameter and a greater height for the dimensions of the volume of that. Liquids are, the particles have a bit more space between them, so there's a little bit of compressibility, but they're still quite tightly packed compared to gases, and so there's not a lot of compression that can happen in liquids either, just more than in solids. So here we have intermediate forces of attraction, or intermolecular forces between the particles, which will still hold the particles close to one another, but they're not as strong as in solids, and so this time the particles are able to move past one another. So because of that, we have not only the vibrational motion for particles, but they also can rotate and they can move in straight lines. So the only thing is that all of the particles are going to remain in a similar area. So although this particle could move in a straight line this way, it's not going to move in a straight line up and away from the rest of the particles. And gases, so this is what our unit is going to end up focusing on, although understanding the behavior of gases can be easier as we talk also about solids and liquids, because then we can tell in relation to those and understanding how those behave, we can have a deeper understanding of that. So gases, the shape of those can change. So depending on the container it's in, so if I have a container here with a lid on, this is the shape that that is going to take. And if I open that up, then whatever closed space, so if I have a closed room, it will completely spread out and take the shape of that container. That also means that the volume can change. So the particles here are going to spread completely out in this jar. And if the lid is taken off, then it will spread out even more into the room that jar is in. So gases can change their volume, and that is going to be based on the forces and the types of motion, which we'll talk about momentarily. Because gases are able to move far away from one another, they're very highly compressible. So there's a lot of space in between neighboring particles, which means that we can push them together. So we can compress them by forcing them to be close to one another. So if you think about a propane tank for a barbecue, the tank can be quite heavy, and that is partially due to the thick walls that are required for the pressure that is needed to push those gas particles really close to one another. Otherwise, we would need a very large tank sitting next to our barbecue, which would not be great. So here the forces of attraction between particles are weak or non-existent, so there's no force holding them near each other, which is why they can move off far away from one another, and there's a lot of space between them. And because of that lack of forces, not only will particles vibrate, but they can also rotate, and they can translate or move in straight lines. And unlike liquids, they can move far away from one another.